All right. So hello, everyone, and thank you for joining us for today's webinar. My name is Alex Bernard, editor of Fruit and Vegetable Magazine, and I'm joined today by David Percival, professor of plant physiology at Dalhousie University, and Anne McCrae, senior technical service specialist for horticulture and insecticides with BASF. And before we begin, I'd like to thank BASF for sponsoring this webinar. BASF has a diverse portfolio of fungicides, herbicides, and insecticides to help you manage fruit and vegetable pests all season long and maximize yield and quality of your crop. Thank you, BASF. Today, during our session, David and Anne will discuss challenges growers are facing related to disease management in blueberries with a focus on botrytis control. And I'd like to remind everyone that this webinar is being recorded and will be made available to all attendees and registrants after our live broadcast. Give it a few days. This session is scheduled to run for approximately 60 minutes. David and Anne will speak for about 45 to 50 minutes, at which point we will start the Q&A period. If at any point you have questions, please type them into the questions tab. You'll find it at the bottom of the screen. And without further ado, I'll let David take it away.
Okay. Well, hi, everyone. I'm David Percival. I'm a professor of whole plant physiology, as Alex mentioned earlier, at the Truro Agricultural Campus of Dalhousie University. And it's my pleasure to give an overview of disease management practices that we're using, in particular with the use of Bacillus compounds in wild blueberry production. And so the research here I work with is collaborative in nature with the producer associations in the Maritimes, as well as the Bragg group of food companies being helpful with respect to these research activities. Yeah, as far as what I'll be going over today, I'll be providing an overview of what I do as far as the research program itself is concerned, and providing a bit of a background on the sector itself. It's quite unique when you compare it to other horticultural crops. And this will then provide some insight into the need for technologies, including the Seraphyll, for use in disease management of blueberries. And then I'll also give some insight then into its application, both in the present and then also in the future. So I have the Wild Blueberry Research Program situated here at the Faculty of Agriculture. And in addition to being the director of the program, I also look after the research facility at DeBert. And along with that, I'm presently the chair of the Vaccinium Working Group of the International Society for Horticultural Science. So if anyone's interested, we're hosting the 13th International Vaccinium Symposium, which is going to be starting in Halifax on August 24th of this year. And so the research program itself consists of approximately 10 to 15 people, including postdoctoral research fellow, Ola Pula, who looks after the remote sensing, research assistant, Emily Kirkpatrick. Typically, we have approximately 4 or 5 research interns or summer students, and then the graduate students. And we have Kenneth Anku, as well as Naomi Jackal. And it's Naomi that's presently working on disease management of wild blueberries. So here's the group, and this was at the conclusion of last year out at our DeBert Research Facility. And when you look at the research program itself, it has 3 main priorities, consisting first and foremost, trying to keep our cost of production as low as possible by examining and developing various technologies. Also, which is critically important, is looking at methods to improve the sustainability of the production system and to address any, especially on the pest management side, some threats as well as opportunities that might arise. And then try to differentiate from other fruit crops, and especially the cultivated high bush, which is becoming more and more of a prevalent player in the global production of wild blueberries. So looking at wild blueberries, just to give you a little bit of a background on it, so blueberries are a member of the heath family, and within those you have really 2 major players consisting of blueberries and then cranberries. But there are some other fruit crops, including lingonberry or partridge berry, as well as bilberry, that's produced predominantly in Europe. So with respect to our wild blueberries, what they consist of is native stands of 2 predominant species, consisting of the sweet low bush blueberry, which is Vaccinium angustifolium, and then the Canada blueberry, which is Vaccinium myrtaloides. And overall, the Vaccinium angustifolium is far more prevalent in fields. It typically constitutes 80 to about 95% of our fields on a surface area basis. And so when you look at wild blueberries, what allows us to differentiate between the two is the sweet low bush blueberry tends to be a little bit of a shorter plant. It also doesn't have the hairy stems that the Vaccinium myrtaloides species has. And from a compositional perspective, the sweet low bush blueberry, it also tends to be a little bit more pleasant to berry. It isn't quite as stringent as the myrtaloides. As far as the production itself is concerned, we're situated throughout the maritime provinces as well as Newfoundland, and actually the largest producer of wild blueberries now is in Quebec, so in particular the Lac Saint Jean area. But overall, now the wild blueberry sector has the potential to produce well over 350, 400 million pounds of fruit. And it's also presently Canada's largest fruit crop when you look at it on an area perspective. Okay, so these are what our fields look like. So this is a good representative field situated here in Nova Scotia. That was taken last July. And we just have some drone footage going over one of these fields, and this field's in the crop phase. And what you'll notice is there's nothing planted as far as the blueberries are concerned. It's just existing native stands. You do have some bare areas and then also some weed pressures. So very much focused on just managing these existing stands of blueberries versus the cultivated high bush, which relies on plant material that's brought in, a lot of amendments to the soils, and then just a far more intensive management plan that needs to be used in producing this crop. So our cycle is a little bit different as well in that we use a fairly aggressive pruning strategy. So the plants are mowed right down to the ground level to start the production cycle. So this can be done either in the late fall after harvest or early in the spring. The new shoot uprights will come up from the rhizomes, and what makes the plant interesting and unique, it has a massive root and rhizome system. It constitutes about 75, 85% of the plant's dry matter content. So just a massive root system, which allows it to be quite stress tolerant. And the shoot uprights, they'll be growing well in past July, and in which case they'll start to form floral buds, which will overwinter. And then in the spring, these buds will come out of dormancy, they'll start to swell, and then shortly thereafter, they'll come into bloom. And you can notice in this particular slide the differences in the coloration associated with the population structure and the differences in it, with the flowers ranging from white to almost pinkish hue when you look at the variability. The flower itself is interesting from the perspective that it all has to be cross-pollinated to get an adequate sized berry out of it. So it requires a massive movement of pollen in a field. So we're very much relying on pollinators, so honeybees in particular, as well as bumblebees, for this to occur. And when you look at the structure of the ovary, it's an inferior ovary. So the fused petals, what we call the corolla, actually attaches about midway up on the ovary wall. And this poses some challenges that I'll talk about later on. So the single biggest expense with respect to producing wild blueberries is the rental cost of the pollinators. And you can see in this particular case, this is a good example where we need at least anywhere from 2 to 6 hives per acre in order to ensure this pollination occurs. Then approximately 68, 75 days later, the berries have ripened and they're ready for harvest. And the berries are mechanically harvested. They'll be put into these large tote boxes, and then they're off to the processing plant where within a period of 12 hours or less, the berries are frozen into individually quick frozen berries and then marketed globally. And presently there's fruit going to over 40 different countries when you're looking at wild blueberries. So when you're looking at the production of blueberries, they're very much depend also upon the presence of microbes, and the microbes, they can be classified as fungi, bacteria, viruses, slime molds, algae, protozoa, lichen, archaea, prions. What I'm really going to focus on in this presentation are the pathogenic fungi, and then also the beneficial bacteria that can be found and used as well. So when you're looking at blueberry production, there are some fungal pathogens that can cause issues below ground. And so examples of this are Amelia root rot and Phytophthora root rot. And we do have a little bit of Phytophthora that can occur, especially in years of drought stress in our wild blueberry production, but generally it's not too much of a concern. When you look at the above ground diseases, though, one that can be quite explosive and is challenging to manage is Botrytis blossom blight, and it's caused by the fungal pathogen Botrytis cinerea. And so if you're to look at the diseases that cause us concern in our production cycle and the cropping phase of it, we start season off right after bud break with monolinea blight. And then after this is when our Botrytis blossom blight becomes a concern. And this starts at the early stages of bloom all the way through to fruit set. And then also we can have some issues with leaf diseases in the cropping year. And two used to be known as septoria leaf spot, and now we realize there's more than one causal organism. So the other being spherulina leaf spot can also occur in blueberry fields as well. And we also have these other minor diseases ranging from Exobasidium, which can cause spots on the fruit as well as white lesions on the leaves, and then also powdery mildew, Valdensinia leaf spot, and these sorts of things. But by far the most damaging is Botrytis cinerea, and it's the causal organism Botrytis cinerea. It's a weak saprophyte. The ideal tissue that it typically colonizes is the corolla, especially as it's nearing the end of the bloom window and it starts to break down. And what is also a challenge is the infection can occur with as little as 8 or 9 hours of wetness durations. So it can be quite an explosive disease. And it can be further aggravated if you have any frost events, and then also the coastal fog that can be quite problematic, especially here in Nova Scotia. And we also see it occurring on some alternate hosts, such as various weeds, including sheep sorrel as well as brambles. And it's a pathogen that overwinters, present not only on the stems but also in the plant debris, so prunings, leaf litter, and these sorts of things that are present within the field. So the primary inoculum source can be quite prevalent in fields, and then when you look at it, it'll then disperse quite readily as the growing season progresses, both in the form of conidia, okay, and then also it'll overwinter as sclerotia in the soils as well. Right, so when you look at our fields, this is a good example of one that's coming into bloom. So we can have anywhere from 100 to 150 million flowers per acre. So there's a lot of floral tissue that'll be present in these fields. Duration of bloom is approximately 3 to 4 weeks. And it's during this time where botrytis can be quite problematic. And this just gives you an example or insight into how our floral displays can be quite prevalent in some of these fields. And so when we monitor for botrytis, we really take almost like an ABC approach. So we pay careful attention to the stage the plant's in. So the early stages of bloom. So when they're at that unopened white petal stage is when the process really starts for monitoring for Botrytis cinerea. On the sporulation side, because our primary inoculum source tends to be so prevalent, we assume it is. And then we also pay close attention to the environmental conditions, and in particular temperatures as well as wetness duration. And as far as a predictive model on then determining, okay, have I had an infection event or not? There is this nice interaction of temperature with wetness duration. So a good example is if you have a nice warm day, 20 degrees, and your wetness duration is extended beyond 10 hours, in all likelihood, you've had a high likelihood of an infection event occurring from a physical environment perspective. And so then looking at how our cropping year season can progress, really the monolinea blight is what occurs first in our season. And so traditionally, it's been one that's been quite easy to manage with the presence of triazole fungicides, such as prothioconazole. And then when we get into the botrytis blight blossom window, it's one that is a little bit more challenging, just given some of the resistance issues that we've been running into. So this is what the botrytis itself looks like when you're looking at the conidia that are involved, and then also the conidia-4 structures that are holding them in place. And so with botrytis, it's very important then to make sure that you can, if at all possible, get a disease control product on before an infection event occurs. And then to also then make sure you have the protection in place to last the duration of the bloom window. So in other words, when there's risk for botrytis occurring. And this has become particularly important as we've looked at the botrytis isolates that we're collecting from our wild blueberry fields. So we've gone through the process of building a library of the various isolates from the maritime provinces and looking at how they're responding to the presence of some of these active ingredients. And some examples of this are, in the past, we made extensive use of the fungicide Pristine, which had the active ingredients bosclid and proclostrobin situated within them, as well as some other active ingredients. And what we found is, in the case of bosclid, which is situated in the top left of this particular figure, a lot of our isolates just had a right resistance to this particular active ingredient. And then even with the proclostrobin, we were seeing some fairly significant selection pressures as well. So what this then made us realize is our tools in the toolbox, as far as selection is concerned, was getting increasingly less, and especially since we were even seeing some resistance with just a few, not really evident in this particular diagram, but there are a few that are even resistant to fluoroxanol. So as a result of this, it really made us open our eyes and realize there was a need to look at some alternative management strategies. So some of the key things then that we focus on when we're trying to manage for botrytis blossom blight is also be aware that we have other diseases that are going to be present in the field at the time. And I'll show you some other examples of this. But Anthracnose, Exobasidium, Septoria leaf spot, they're all present when this botrytis blossom window is occurring. We need to also make sure that, especially after bloom, when fruit sets occurred, that the fungicides we're using, we will not run into problems with them in export markets, because over the majority of the crop produced in Canada is exported, with markets including the European Union being really, really important. And to also keep track of the field history, because especially coastal fields that have history of botrytis, significant botrytis problems, in all likelihood, they're going to continue to be problematic, just given the variety of these factors. And what's also important is for producers to only use products that are been approved by their processors or end users for use in their area or production system. And as a result of this, you really need to make sure that you have the approval of the processor for this to occur. So with that, what I can do is really then key in and focus on some of the specific research that we've been doing with respect to the use of the Serafil. And a lot of this work has been done over the last 10-year period. And what's important, though, is if you're considering using these products, only use those that are registered for use in your cropping system in your particular area. And also, as I'm working my way through this presentation, the mention of a product trade name does not constitute a guarantee or warranty of the product by Dalhousie University. Okay, so when we're looking then at the biofungicides, we started to look very carefully at them approximately 10 years ago. And Serenade was one of the ones that we initially looked at, but then we subsequently switched over to looking in more detail at Serafil, as well as others, including double nickel. Other kind of biofungicides that we've looked at include various polyoxin, the BVT, CR7 products, as well as Protector, for use in wild blueberry production as well. And so some of the work that's been published, looking at how to control botrytis in wild blueberry production, includes work done by Joel Abbey, which included the use of the biofungicides. And as I mentioned, the various biofungicides that we've examined include those that are listed here. Okay. And we've also then looked at how the botrytis can be managed throughout the cropping cycle in the wild blueberry production system. And this was also additional work published by Joel. And then how these biofungicides can be used in concert with, so combined with, or rotated with conventional fungicides for the management of this disease in wild blueberry production as well. And so when you're looking at the Seraphyll in particular, and it's how it works, we found some really interesting results in addition to those that are presently available as you look through the literature. And so we know the Bacillus organism can produce metabolites that help hinder the growth and development of botrytis. We know that they compete for space, especially on the surface of the berry. And being present on the berry, it also compete for resources, okay? And it'll essentially mop up any residual nutrients that might be present on the surface of the berry and the floral tissue. And one of the reasons why the product is effective in the case of blueberries is it has the ability to work its way in and persist in the floral structure, and then also in the nooks and crevices of a developing berry as well. And so this is what's allowed this product to be quite effective as a disease management tool. And when you look at, in particular in the Maritimes, it has been widely used in concert with other fungicides for the past 2 seasons now. And on the research side, what we've also found out is it's actually use of the bacillus has also been observed to trigger the plant's defense mechanism as well, and kind of bring in a resistance to some of these problematic diseases. And this is what Joel Abbey, who's a PhD student of mine, worked out over the course of his PhD program. And with it, what he did was he looked at not only the response of what was being caused by the plant as far as a resistance response in response to botrytis, but also he has found that this response was also being facilitated by the presence of the Seraphyll. And we noticed that over time, whether it be just the application of botrytis cultures or independent of this, the application of the Seraphyll was causing these resistance genes. So that it's referred to as the PR3 and the PR4 to be upregulated. And then as a result of this, the kind of cascading effect as far as the response the plants would take in trying to minimize the damage caused by this causal organism. So we observed, which was actually quite interesting, is that the bacillus did trigger the plant's defense response. Some other things that were observed when we looked at applications of the Seraphyll to the blueberries was we found that the photosynthetic rate also increased, and we observed that looking at the 3 phenotypes that we used in this particular part of the project, so just our standard Vaccinium angustifolium clone, also a Forma nigrum, which produces a very dark berry, and then the Myrtaloides, we found that initially, in response to whether it be inoculation with botrytis or with Seraphyll, the photosynthetic rates actually went up. And then they stayed high in the case of the application of the Seraphyll for quite a considerable period of time. Whereas in the case of the botrytis, eventually, we also observed damage then to the canopy and the leaf area, which caused then the photosynthetic rates to drop off. But overall, we did see this increase in the photosynthetic rate as a result of applications of the Seraphyll. Now, as far as the ability to control the disease, what we observed was when you look at, in this particular case, a fungicide trial consisting of an untreated control, our industry standard, which was switch, applications of switch, and then Maravon and the Ceraphil. What we observed was that all fungicide applications reduced the incidence of botrytis, but in particular, the combination of the Maravon plus the Ceraphil was the most beneficial or most helpful in reducing the disease pressure. And this is something that we've continued to see multiple trials over multiple years with this. So it's quite effective at reducing not only the incidence, but also even more so the severity of botrytis on the flowers and then the developing berries as well. So overall, what we've come to realize is given the resistance issues that we're seeing with some of the active ingredients in the conventional fungicides that we're using, having this extra layer of a biofungicide in the form of the Ceraphil really helps reduce the potential for damage caused by Botrytis cinerea in wild blueberry production. And then as far as the cumulative effect of this, over the course of the growing season, come harvest time, what we've also been observing is a nice little increase in yield. And it's not only due to the ability to suppress the botrytis, but also some of the other diseases that are occurring, whether they be in the form of a little bit of anthracnose or alternaria, which affects the berries, but more importantly, the canopy, and keeping the canopy nice and healthy and free of leaf spot diseases. So to summarize this up, we are starting to see that the use of microbes, in particular the Bacillus compound found in Ceraphil, is really providing value to the wild blueberry industry. And it's a cost-effective tool to ensure that the damage caused by botrytis in particular can be kept to a minimum. So it's something that even in the conventional stream for blueberry production is very, very important. And then also with many of the berries going to international markets that have standards of preferring to have absolutely no detectable residues of these conventional fungicides found on the berries, it allows us then to go into bloom with adequate leaf disease control, and then transition to a biofungicide program thereafter, and therefore ensuring that you won't have any detectable residues in the berries once they've been harvested and processed. Okay. And what's also important to note is, as I mentioned in that last point there, is by using these products, it is causing a response within the blueberry plant. And in the process of getting the plant to build up its defense mechanisms, there is a bit of a physiological cost associated to do this, to make in particular the phenolic compounds that are assisting in the plant's defense response. But overall, it is one that's definitely worth it as you look at the implications of this. So with that, hopefully I've been able to provide you with a bit of insight then into the potential of using Ceraphil as a disease control product, in particular for use in blueberries. And if you have any questions, I can either take them now, but I'd also like just to mention that we do have this International Vaccinium Symposium coming up. And the dates for it are actually the 24th to the 29th of August, okay, here in Halifax and in Charlottetown. So with that, that concludes what I'm going to ask, and I'll pass it back.
Perfect. Thanks very much, David. That was great. I'm just going to, I'll start on mine. I'm going to share my screen, and then I think there'll be time at the end too, if there are questions people want to put in the chat, and then we can cover all the questions at the end too, because we should have lots of time. All right, hi everyone. I know I was introduced at the beginning. My name is Anne McRae, and I work with BASF. I am here to just talk a little bit specifically about Ceraphil, actually. I wanted to cover a little bit about what the product is, sort of best use practices, and a little bit about what's going on when it's applied. So just to start off with, I know that beneficials are certainly being talked about more and more now, especially these biofungicides. They've in the beginning maybe got a bit of a bad rap, or were sort of seen as more of an organic only product, but they're being incorporated a lot more into sort of that conventional chemistry programs. And so I'm going to talk a little bit about that too, but also, as Dr. Percival mentioned, gives us some flexibility as far as your MRLs and things like that when you're worried about exporting your product. For Serafil, this is a Bacillus amyloliquefaciens. There are a number of Bacillus products out there, and some of them, they work similar and yet have some differences as well. So I'll talk a little bit about that. Ours specifically is a strain MBI 600. So that's what makes it unique, is its unique strain. It actually helps to manage a number of diseases, and we have it registered in a number of crops, and we're continuing to do research in other crops so we can continue to expand this label. We hope to add more crops soon and more diseases, because we think this product works in a lot of different ways and really helps out growers looking for alternative solutions. So I'll also talk a little bit about sort of tank mixing with chemistry-based programs, and then a little bit around sort of a quality, purity question and what that looks like with biologicals. So this was touched on a little bit in David's presentation, just talking about the different modes of action. So traditional chemistries, when we're thinking about, frac groups, so like a group 7 or a 3 or 5, 11s, things like that, you're talking about a specific site of action. And usually they have one mode of action because there's one place that they will target, and that's what kills the pathogen. The great thing about biologicals, Serafil especially, is that they actually have 3 modes of action. And that's just because they are a live organism, and they will reproduce in a space, so they'll take up that space so nothing else can grow there. So that would be one mode of action. They also compete for nutrients. So in the case of Serafil, it will colonize on that space, take up all those nutrients, and then the pathogen couldn't survive there either, as well as fungicidal metabolites. So there was a little bit talk about metabolites. I'll talk about that a little bit more, but they do actually produce something that will attack other pathogens and kill them, which is also kind of neat. Another thing to note about Bacillus-based fungicide labels, generally when we're talking about your label, if you're looking at traditional chemistry, you look at a rate per hectare or per acre, and it's the amount of active ingredient in that liter, in that gram. With Serafil, you look at more of a CFU. And what a CFU is, colony forming units. And those are actually in the billions per gram. So it's actually the number of spores, or the number of live spores, that are in every gram of product. And that can actually vary based on the product that you're using. So it's important to kind of take a look at that. Maybe the rates may seem all the same, but you could have a very different number of live spores that you're actually applying onto your plant. And the more live spores you have, then the better efficacy you get and better results, because there's more live spores to colonize that space. Just to kind of go along with that, sort of what happens after you apply it. So you have your Serafil application, and then as I mentioned, it colonizes that space, takes up the nutrients, but it also produces those metabolites that we were talking about. So if you have, sometimes there's a question of temperature, and I do have a slide kind of on the best temperatures for your biologicals, but they also, in Serafil's case, can create metabolites and colonize even at lower temperatures. So kind of that 10 to 20 degrees, Serafil will actually produce a metabolite called surfactant, which does kind of what it sounds like. It's called surfactant because it's similar to a surfactant that helps it stick. And that's why we have a rain fast of about 3 hours. So it actually will stay on the plant. It doesn't just wash off after it rains, as long as it's been on the plant for about 3 hours. Then when you get into a little hotter temperatures, that 20 to 30 degrees, when that ideal temperature for pathogens to be also growing and spreading, Seraphyll actually produces this metabolite called iturin, and iturin is the one that actually attacks fungus, like your fungicide spores. That's also an excellent thing to help to reduce your disease and to manage that a little better. And then when you get too hot, just like it can be too hot for the disease, it can also be too hot for a Bacillus product, then it kind of goes dormant, but doesn't necessarily die. It just hits a dormancy. So a little closer look at some of the influence of temperature for Seraphyll. Key thing to note is it is still working at those lower temperatures, but it works best at those warm temperatures, moisture, at the same time that's for, like, say, a botrytis would also prefer those warm temperatures and moisture. So it will grow really well, it will colonize more at the same time that your botrytis is trying to colonize more, which is exactly what you need it to do. This is just another way to kind of show, specific to botrytis, how Seraphyll works. So in these pictures, you'll see we have a Petri dish. So what they did is they colonized botrytis on the lid of the Petri dish, and then they flipped it over and put it on top where there was Seraphyll already colonizing in the middle. And what you'll see is not only did the Seraphyll protect itself where the spores were, but it also creates this zone of exclusion. So this is the metabolites that are all working around the Seraphyll to protect it. So it's killing all of those botrytis spores in that sort of zone. What that means is it's also very important that this product is applied preventatively. It really almost doesn't work if it's a curative application. So if you know that botrytis is already present, this is kind of what happens. They applied the botrytis first and then Seraphyll after, and the botrytis just had already taken over. So the Seraphyll couldn't compete. Now, if they were applied at the same time, so you had a botrytis spore placed in the Petri dish at the same time as your Seraphyll, they kind of take up their own space. So they both start to colonize and they both take up their space, but the Seraphyll is protecting its area where it is growing. Now on the reverse side, if you applied Seraphyll first and it was given the time to colonize and spread those metabolites, it does a much better job of almost removing that botrytis from the area. So that's our ideal time, is we'll always talk about preventative applications with biologicals. So Seraphyll also combines really well with your standard fungicides, which was interesting because a lot of times you will get questions on, well, I wouldn't want to put this with any synthetic chemistries because it'll probably just kill the bacteria. But what we have found is that it actually helps to boost the Seraphyll a little bit, and it helps it work a little better. What we saw in some of these trials that were run, and this one specifically, mostly with group 7s, but we looked at Cantus, which is a group 7 fungicide, and Pristine, which also has group 7 in it, as well as Maravon, which was mentioned earlier. We found that so in the left-hand side, you'll just see Seraphyll on its own, and sort of these reddish pink lines are the spores, and they're starting to colonize and create metabolites. But when we added that chemistry to both of these, you can see all of these little sort of orange streakiness in between and even more spores. So it almost had a stress response where the Seraphyll is like, I have to grow faster now. And there was more of them and it created more metabolites. And so with that, you're also seeing that increase in efficacy over some of the diseases, which was great and a really interesting find. So we do recommend that you can use this on its own in rotation with chemistries, but it also really works really well in a tank mix, especially when you're trying to control botrytis. Like putting the two together is the ideal situation. So along with compatibility, the work we did kind of looking at the stress response of Seraphyll spores was mostly with group 7 fungicides, but we did do some compatibility testing just to see, is it okay to tank mix this and will it kill the Seraphyll spores? And so all of the products on the screen here we've tested They don't all necessarily create that stress response, but they do work well when being tank mixed. They can be tank mixed and it won't hinder the Ceraphil whatsoever. So that's a big list and you don't need to memorize all those. The key ones were that we did find 3 products that if you mix at all with Ceraphil, it will actually kill the spores. So we do recommend your Bravos and your Manzates and things like that to not tank mix that with Ceraphil and leave about 7 to 10 days between applications so that your Ceraphil gets a chance to work before switching to one of these products. And so just general management practices as far as rates go, we have a rate range. We find if you're using a higher rate, it just means you're putting more spores on, which always works better. So high rates when used on its own is generally has higher efficacy. Lower rates work just fine, especially if you're using it as a tank mix. So you could go lower rate just to be a little more economical when you're tank mixing it with other traditional chemistries. This product is not systemic, so it colonizes on your leaf surface. So you want to make sure you have high water volumes and you're ensuring good coverage of the whole plant. There isn't really issues as far as pH goes if you're concerned about pH of your water when mixing. And any surfactants can be used as well. I had mentioned earlier, because of some of the metabolites created, that it has a rain fast of 3 hours. And the re-entry interval is 4 hours, which is nice as well when you have maybe certain crops that you want workers to be into as soon as possible. Then this has a little shorter re-entry interval than your traditional chemistries, 12 hours. And 0-day pre-harvest interval because it's sort of residue exempt. So MRL status is exempt just because there are not detectable residues when you're using your biologicals as well, which is great. All right, so that's sort of my review of Ceraphil. I did just want to add on here, first of all, thank you for listening to our webinar, but also that if you want to learn a little bit more about Ceraphil or any of our other blueberry products, there's information on Maravon, which we spoke about briefly, just around what diseases it covers and what it does. We also have a new fungicide called Sevia that is now registered in blueberries. We just received registration last sort of late spring, early summer. So you can go to the website eggsolutions.ca/horticulture. It'll have these lovely charts in our crop guide, or any of these products that you can look up and you can learn a little bit more about how to use them and what diseases they cover and things like that. So I welcome anybody to check that out. And thanks very much for listening. And I'll turn it back to Alex and we can do any questions.
Perfect. Thank you so much, Anne. And thank you to David for both of you for the great presentations. We've got a few questions for you folks. The first one goes up to David. Can you explain more on why you think there is a benefit to Ceraphil for reducing botrytis pressure under field conditions when the Maravon plus Ceraphil treatment was statistically equivalent to Maravon, Switch, and Miravis Prime treatments? It's in the Q&A tab if you'd like to read it.
Yeah, I'm just having a look here, seeing if I can find that. So yeah, so of course, when we do a presentation like this, you have to pick one out of so many field trials, right? Now, so to get back, okay, well, why do I see it as having a potential benefit compared to just a straight conventional application? I think what we should do is clarify a little bit and just try to set the stage a little bit more appropriately with respect to how we manage the disease. So going into the botrytis window, the conventional fungicide that's still getting a lot of attention and use is Switch. The problem with it is there is resistance. We know just flat out right to the cyprodinol situated within it. The fludioxonil is still good as an active ingredient, but it's starting to break down. So we do know in time it's going to be one that potentially we're going to see more and more resistance to it. What we're able to gain by using the Maravon along with the Ceraphil is, well, compared to cyprodinol and fludioxonil, you have two completely different modes of action in the Marathon, both respiration inhibitors. And then on top of that, then you have the various benefits associated with the Seroquel. So when you look then at coming in and trying to rotate your active ingredients and reduce the likelihood of resistance, it's a good way to achieve this. And then overall, although I didn't show you, the other trial data, it is one that consistently has performed better than just the conventional fungicides alone. So that's the history of it. The other thing I'll mention, which I think will also come into and help answer some of the questions, is when you look at this rotation, it's been used commercially widespread, thousands of acres now, for the past two field seasons. And now what some of the growers try to do is wait till after the bees are gone before they come in with this particular combination. And then also, just because the leaf spot diseases tend to escalate towards the tail end of blooming shortly thereafter. But we haven't seen any problems that I've been aware of that bee health has been hindered as a result of this combination.
Okay. Yes, we had a few questions about the bees. So
Yeah.
And do you have anything more to say on the subject of bees or pollinators?
Yeah, so I should have added too, we do have, so first of all, with the bees, it has low to, I guess you can never say no impact, because if anything was sprayed on a bee, it would kind of shock it. But yes, no impact on like bee colonies or brood or anything like that. So safe to use that way. We do also have the EcoCert certification for organics and OMRI certification in the US, I believe it is. So as an organic product. Yeah.
Okay. I'm not sure if this can be answered, but I'll ask. Can Seroquel, I imagine this is, be used for citrus post-harvest diseases?
Oh, citrus. So that's a good question. We have an extensive US label for Seroquel. So I would say just check out the US label. It is a possibility. It covers a number of diseases. I just can't remember offhand whether it had citrus or not. But yeah, I would just say take a look at the US label.
Not typically something you see a lot of in Canada. Is Seroquel compatible with casugamycin? Slide that Anne shared had streptomycin compatibility.
Right. Yeah. So we haven't tested that one specifically. Streptomycin is the only one that we looked at. I would imagine it's hard to say with those because they're so specific, but so I don't know for sure. Probably okay, but we haven't looked at it.
Okay. And would you recommend applying a biofungicide before or after a conventional fungicide to either of you?
From either is fine. From my perspective, it could depend on, and maybe David can comment on this, on when your pressure is coming in. So if you know you have high pressure, then that's best to pull out the synthetics with the like tank mixing them. Sort of those Seroquel works well on its own under low pressures.
Okay. If we have any more questions, now's the time. But now it's time, I guess, for my questions. Any more questions? For Anne. Oh, okay. David, what percentage bloom did you spray in your trials?
Okay, so and this is, again, I showed one trial, but we've really started right at the 10%, so pre-bloom, and carried it all the way through to fruit set, which is at that shatter stage of the bloom. The bulk of the trials really are just at or shortly after full bloom. is when we really try to key in with the use of the product. Yeah.
Okay. And for Anne, can you repeat products that Sarah felt is not compatible with? I think I saw Mancozeb on there.
Yep. So chlorthalonil products, so your Bravo Echo, Mancozeb or Manzate, and Metalaxyl. 3.
Okie dokie. Well, thank you both again for the presentations today and for answering the questions. And thank you again to BASF for sponsoring. Oh, sorry, we did have one more question come in. Oh boy. What was the compatibility testing done with formulated products or with active ingredients only? Could other things in the formulation impact compatibility?
Oh no, it was done with all commercial products. We usually just collect like by the product specifically and run the testing. Yeah.
All right. Thank you again and have a great day, folks.
Awesome. Thanks very much.
Thank you, everyone.